Hello viewers, today we'll be discussing polymers and we'll be discussing a specific topic of polymers known as fibers. Let's understand what's fibers first. The typical definition of fiber includes the filaments which have their length 100 times of their diameter. These polymeric fibers are also known for their tensile strength in the industry. Now we'll understand the categorization of polymeric fibers. All the fibers we study and we know have been classified into two categories. First is polyamides. So the polymers having fibrous structure and have repeated polyamide linkage. You can see this functional group C double bond ONH. This is known as amide linkage. So all the polymers which have this functional group repeated in them, we call them as polyamides. Second is polyesters. Similar to polyamides, these have repeated polyester linkage, that is C double bond O, ester linkage. So when we see these repeated linkage in any polymer, we call it as polyester. Now let's first start with polyamides. Polyamides have repeated polyamide structure like we just discussed, C double bond O NH2. Some popular polyamides fibers which are famous in industry and are commercially used vastly are nylon 6,6, nylon 6 and Kevlar. Let us study how they are synthesized, what are their properties and applications in detail. First, we'll study about nylon 6,6. Nylon 6,6 have monomers hexamethyldiamine and adipic acid. You can see hexamethyldiamine is a diamine having both the ends with the NH2 and it has 4 methylene groups over here. 6 methylene groups over here. Similarly, adipic acid is a diacid. You can see the terminal bonds are having carboxylic acids and they have 4 methylene groups. When we put them together and we go through condensation polymerization, one molecule of hydrogen removes from the diamine and OH gets removed from the adipic acid, resulting in the subtraction of water molecule, which is a small molecule, resulting into the condensation of these both monomeric units. And the result is nylon 6,6, which is a polyamide fiber. Now, the properties. It has high crystallinity, it has high tensile strength, high melting point and elasticity. It is tough and resistant to abrasion. It has good abrasion and moisture resistance. They are used in manufacturing of socks, foams, brushes, carpets, gears, brushes, and molds. Now, we'll study about nylon 6. Nylon 6 has monomeric unit known as caprolactam. Caprolactam first is synthesized by cyclohexane itself using a known rearrangement reaction known as Beckmann's rearrangement reaction. So let's first go on the first step, that is the preparation of caprolactam. Here in this reaction, you can see a series of organic reactions beginning from cyclohexane. When we polymerize cyclohexane in the presence of oxygen, it oxidizes and gives cyclohexanone. That means this carbon that converts into the ketone. Further, we'll react it with NH2OH, condensation will happen, and here the formation of oxime will be happening. This is the final and the defining step of the reaction. Here, when we use H2SO4, Beckmann's rearrangement occurs. This nitrogen is pulled inside this ring. So here you can see it's a 6-membered ring that's converted into the 7-membered ring. No elimination is there, just the rearrangement is there. This nitrogen gets inside the ring, so the number of the ring increases. This is known as caprolactam, which is the monomer of the nylon 6. Now, what we'll do, we'll prepare the nylon 6 using the caprolactam. First step is ring opening phenomena. This caprolactam is heated and this is a labile bond which breaks and gets into the fragmentation form. So you can see NH here, NH is here, 1, 2, 3, 4, 5. 5 methylene groups are there, ending with C double bond O group. These fragments will be equal to the number of rings we have used over here. And further, when these fragments are polymerized, you can see same, these get end-to-end attached, bringing about the formation of nylon 6. Because of the formation of caprolactam, nylon 6 is asked many times in the examination over the years. Let's discuss the properties of nylon 6. Nylon 6 has high tensile strength and high modulus. It comprises elasticity and luster. The application includes uses for making bristles of the brushes, in textile for making sheets. It is blended with wool to make socks and sweaters, and it is used for manufacture of cords and ropes. Popularly, these are the major applications of nylon 6. Next is Kevlar. Kevlar is also a polyamide. It is made up of monomers paraphenylene diamine and terephthalate chloride. You can see over here, these are the aromatic diamines, and this is an aromatic dichloride, right? Here also condensation reaction occurs. Chlorine is liberated from here and hydrogen is liberated from the diamine. So HCl is eliminated in the condensation and we get Kevlar. You can see it has two aromatic rings extending the conjugation. Kevlar is a specialty polymer also because of its high strength. It is an extremely strong, often stronger than steel on weight-to-weight basis. It has lightweight, which is advantageous in application where weight is a concern. They have high resistance of temperature, that is, it can upstand the temperature around 450 degrees centigrade, and this is why it is used in firefighting suits also. It is resistant to many chemicals, making it suitable for use in harsh environments, and it has low electrical conductivity. It's a poor conductor of electricity, providing insulation properties, and this is why majorly it is also known as space suit material. It is used in body armors, well-known application in bulletproof vest and helmets due to its high strength to weight ratio, ability to absorb impact. Also is used in aerospace applications such as reinforcing components of aircraft, space structures where its strength and lightweight properties are advantageous. Also used in sporting goods, used in sporting equipment as racing sails, kayak hulls, and protective gear for sports like cycling, motorcycling due to its strength and abrasion resistance. Now we come on to the polyesters, the fibers which are having ester linkage, as you can see over here, C double bond OO. This is the ester linkage. Now, terylene is one polyester in your course, so we'll study about it. It is made up of monomers dihydroxyl, diethyl terephthalate, and ethanol, ethanediol, that is 1,2. So here also, condensation reaction occurs. This is ethanediol and this is terphthalic acid. Acid removes the hydrogen and OH has been given from the alcohol. Removal of H2 occurs. You can see over here. And we can see polyester linkage found over here, resulting into the polymer known as terylene. It is also popularly known as TAP. The properties of terylene is a very strong fiber. It will suffer very little loss in strength than wet. It is elastic and possess the property of resisting freezing. It can be set into permanent pleats when subjected to the correct temperature at the time of manufacturing. Terylene is easily washed and dries also quickly. It is non-injured by acidic substances when used in modernization process. Neither bleaches or dry cleaning agents can harm it. Thus, the applications, it is mainly used in making plastic bottles and clothing. It is used in polyester tricotinate as a fashion garment fabric. It is used for laundry usage as automatic clothing vacuum packing machine, and it is used to make non-woolen needle punched carpet, particularly for the exhibition use. These are the modern uses of nylon 6. These are differences that we have been using to gather all the data, and you can also use to complete a study of the topics we discussed today. Thank you.